Okay, guys, so this is Unit 8. This is Part 1, but I know we've already done a little bit of notes, but this is all about balancing chemical equations. We've talked a little bit about this with the recipe and the different parts of the equation so far, so hopefully you'll catch on to this really. Okay, so first of all, you need to know the reactants and the products. The reactants are the left side of any chemical equation, and they are what reacts to form a bond. So like this is the same equation. This one's just written in elements in the words. So this is the reactant side. And what the reactant side produce is called the product. So this is the product of them adding together and bonding, okay? So this would be the product side. And like I said, this is the same equation, it's just written in symbols. So this is the reactant side. These are what react, and these are the products. Okay. The other thing that you need to know is you need to know law of conservation of mass. We've talked about this concept before, and this is important to pretty much applicable to any science. And law of conservation of mass just says that matter or mass cannot be created and it can't be destroyed. It can change form, but we can't just say poof and something disappears or poof and something appears. But I added this verse because we know that the only time that happens is when God's involved and when He created the earth. But in the Bible, it even talks about how the things that He has created can change form. So kind of interesting parallel. All right, here are the rest of the parts of the chemical equation. So we already said that the left side, this is the reactants. The right side is the products. That's a really bad P. Products, okay? You need to know that this is the yield sign, this little arrow. This is chemistry's version of the equal sign, and we've already talked about this. The big number in front, right here and right here, this is called the coefficient. Okay, and then this little number, we've talked about this is called the subscript. This subscript tells you how many. So the reason why we talk about all of these different parts of the equation is because to balance it and to obey the law of conservation of mass, what you have on the left has to equal what you have on the right. So for instance, in this equation, on the left side, I have 2 magnesiums, okay? 2 magnesiums, and you can tell because it's got that coefficient of 2 and then magnesiums, okay? On the right side, on the product side, I have 2. This 2 goes to both of these. It goes to that magnesium and it goes to oxygen. So on the right side, I have 2 magnesiums. So my magnesiums are currently obeying the law of conservation of mass because I started with 2 and I'm finishing with 2 in the products. Now, I'm going to go look at the oxygens. I have 2 oxygens, okay? And I already told you that this coefficient of 2 in the products goes to the oxygen. So in my product side, I have 2 oxygens. So the number of magnesiums has to equal, and the reactants has to equal the number of magnesiums in the products, which it does. And the number of oxygens and the reactants has to equal the number of reactants in the products, which it does. So this is what we would call a balanced chemical equation, and it obeys the law of conservation of mass. What we started with is what we finish with. Now, it did change form. It formed a chemical bond and formed a new compound, but it's still the same amount of things. Nothing disappeared. And this is what I'm going to be teaching you how to do on this next slide. Okay, so here we go. So balancing chemical equations is super simple, and if you need to pause it to write these down, please do, because you need to have these in your notebook. So here are the rules. If there is no coefficient, there's always an imaginary coefficient of 1. It's kind of like I told you in math, if you said 1x, you really don't need to say that because that's the same as just saying x. You took the time to write x, so it's there. So there's always an imaginary coefficient of 1. Okay, so in all of these, there's like an imaginary 1 here, an imaginary 1 in front of the oxygen right here, and an imaginary 1, that's supposed to be an arrow, and an imaginary 1 right there in front of the hydrogen, okay? This is the most important rule. You can never, ever, ever change the subscript when balancing chemical equations. So these little numbers on the bottom, you cannot change those. They are what they are. They stay the same. You can't insert one on the end, like right here. You can never change that. Okay, so I'm going to go to the next slide. The next slide has the steps on it as well, so you can pause it there if you need to write down the steps. All right, so the steps. First, you count how many of each atom you have on each side of the equation, okay? So on my reactant side, I have 2 hydrogens, okay? On my product side, I have 2 hydrogens. So these obey the law of conservation of mass. On my reactant side, I have 2 oxygens. On my product side, okay, and then you have, let me get my pen working again. Sorry about that. And then you have only 1 oxygen on the right. So if I have 2 on the reactants and only 1 in the products, this does not obey law of conservation of mass. So we already know there's an imaginary coefficient of 1 in front of all of these. I know I cannot change my subscript. The only thing I can do to balance this chemical equation is to insert a coefficient. So whenever you start balancing chemical equations, number 1, use a pencil, because it's very normal to erase a lot. Super normal, okay? There's a lot of back and forth trying to get these things to work out. So there's not enough oxygens on my product side. So what I'm going to do is I'm going to add a 2 coefficient here. And remember, I told you that 2 applies to the hydrogen, but it also applies to the oxygen. So I'm going to cross this out. Now, on my right side, on my product side, I have 4. That's supposed to be a 4. I have 4 hydrogens, because 2 times 2 is 4, so that's coefficient times the subscript gives me 4. And then there's no subscript on oxygen, so I've got 2 oxygens. So now if I look, my oxygens are balanced, but my hydrogens are not. So I go back to my product side, my reactant side, the left side, and I've got to get my hydrogens balanced. And I just need 2 more of them, so I add a 2 here, and 2 times 2 is 4, so now I have 4 hydrogens. So I have 4 hydrogens in my products, I have 4 hydrogens in my reactants, so those are equal. I have 2 oxygens in my products, and I have 2 oxygens in my, in my reactants and 2 in my products. So 2 on the left and 2 on the right for oxygen. So this is what we would call a balanced chemical equation. So that's pretty much all you need to know about these. Now you're going to practice these in class. You always want to go back, the last step that I forgot to tell you, you always want to go back and check your work. And at first I want you to show your work like I did at the bottom. This is what we would call our work. Down here, this is work. But once you get good at these, the only thing you have to do is add the coefficient. So checking my work, 2 times 2, I've got 4 hydrogens, I've got 4 hydrogens, I've got 2 oxygens, I've got 2 oxygens. It's balanced. That's it. So you're going to practice this now. We're going to practice this more on Monday. We're going to practice it more on Tuesday. You're going to have lots of time to really get this, but it's actually kind of fun once you get the hang of it. All right, so that is it. That is all you guys need to know. Thanks so much, and I hope you have a great weekend.